With this parametric one, if you just need to check a certain part right there, go ahead and do that, or fast forward to like part D if you just need part D or whatever you want to do there. But they notice they give us the dx dt, and they don't give us a y or the dy dt, but they give us a graph for the y. So if I need dy dt information here, that is going to be the slope of this graph at a particular time. That would be the dy dt. Now for the first part, it wants to know, find the position. For some of the other past problems there, we just want to find an x position or a y position. So we'll start with like the 5 or the 1, and then we'll integrate the dx dt, the dy dt. But here I want to know x and y. And so it tells us that t equals 0. There's our initial position. So if I want to find the position at t equals 3, if I want to find the x position at t equals 3, I start with the initial position, x of 0, and I start it there, and I go to where I want to go. And then, so this will tell me how far my x's went in between 0 and 3, and this is the initial x. So the initial x was 5, and then I could integrate that dx dt. I can use the math 9 in the calculator for that to give me this 9 number and add it to the 5. There's my new x coordinate. Now for the y coordinate, I did a bunch of extra work here that I realized after the fact I did not need. So if you want to go through that and see if that makes sense in your brain, you can. But y of 3, think about it, they gave us y of t. And if I just want y of 3, it's just an algebra notation, y of 3. I want to know what that number is right there. Now, I guess if I was pressed for time, I might go to that -1/2. It doesn't have to be -1/2 there. So what I did to actually find it is I wrote down a couple points, like 2, -1, 4, 0, did the slope, did my point slope format, and then I plugged in 3, and I did get that y value was the -1/2. So you can go straight to that just from your graph right there. And then part A is done, and that's going to be our position because I have the x and the y. Now for part B, when you see that phrase, slope of the tangent line on these parametric problems there, that's going to be the dy dx. And then the dy dx is always equivalent to dy dt over dx dt. Now the dx dt, they gave us that formula. So all I got to do is take the 3, plug it in, and there's going to be the bottom part. But the dy dt, that's the slope of your y function at t equals 3. That's the slope of this at t equals 3. So if you just, and I already have that slope right there, in between those 2 points, that slope is 1/2, which means your dy dt at there is equal to the 1/2 there. So that's where I got the 1/2, and then you could just plug that into the calculator. There's your dy dx, which is the slope of the tangent line. And then letter C is simply your speed of the particle at t equals 3. Your speed formula is just the square root of dx dt squared plus dy dt squared. The dx dt squared, so at t equals 3. So I took the 3, plugged it in there for the dx dt, and then I squared it. And then I'm going to go plus the dy dt squared. That's the slope of the y function at t equals 3, which we just got done talking about in letter B. The slope of that at t equals 3 is 1/2. So that's your dy dt is the 1/2 squared, and then you get that number. Now they tried to throw a wrench at us on part D. Part D almost got me. I was in them. Usually when we have to do a total distance traveled, it's just your arc length formula, which is the integral of that speed formula right there. And you just go from like 0 to 2, but you can't do one single integral here in between 0 and 2, because if you try to go the integral between 0 and 2, you would have your dx dt squared, which is fine because that's the same on both of them. But then when you go do plus your dy dt squared, your dy dt is the slope of your y. Now, if you do the slope of the y graph in between 0 and 2, see how there's 2 different slopes right there. So because there's 2 different slopes, that dy dt part is changing. So that's what you have to know, that you got to go back up. You can't do one integral. You got to break that up. And I'm going to go between 0 and 1, 1 to 2, because I have a dy dt. I have a different slope in between 0 and 1 and a different slope in between 1 and 2. So the dx dt squared part, that doesn't change. But in between 0 and 1, the slope of that y graph is just rise over 1. We're going to go down 2 over 1. So that's -2. So there's your dy dt and squared. And then in between 1 and 2, your dy dt, that's just the slope of that, which is equal to 0. So then you square it. So then that's 2 separate math 9s. So please make sure you're practicing on your own, doing the math 9s right there. So you get your speed up, you get your comfortability level up, you'll feel better about it. Practice and make sure you can get those right numbers. And if not, you'll let me know. Light switch.